Guys, Mr. Bowman here. Today's learning objective is in red and we are learning about Pythagoras' theory. So Pythagoras' theory, we've learned about him and his mate Hippasus. It starts off with a triangle, and I've got one up here for us. Specifically right angle triangles only, and we'll get into more detail about that in a little bit. But what Pythagoras started to do, so we'll work with our triangle, let's say it's 3, 4, and 5 centimeters respectively. He started working with squares. Yeah, squares of all things, even though we're dealing with triangles. So what he messed around with, he found out, well, let's say he's put a square on the end of that side of the right angle triangle. We can see it's 3 centimeters and 3 centimeters, so both are square. He then did it on the other side of his right angle triangle. He's got 4 and 4. And then finally, he's done 5 and 5. So he's put squares all over his right angle triangle. And he noticed something. So if you think of this square, that's going to be 3 times 3, right? Which comes to 9. The square down the bottom, well, that's 4 times 4. And that came to 16. And up the top, he did 5 times 5. Which came to 25. So he started messing around with his squares and he realized something. 9 plus 16, that gets us to that 25 there. So he realized 9 plus 16 equals 25. Another way to put that was 3 times 3 plus the 4 times 4 equals 5 times 5. And that related to the measurements of that. And you can actually say it one more time. Well, 3 times 3, well, that's 3 squared. So 3 squared plus 4 squared equals 5 squared. And this last part, that forms the basis of Pythagoras' theory that we know about. So what I'm going to do is I'm going to link to that, and we're going to run through the key elements and the equation that we can use for Pythagoras' theory. So just to help our diagram, I'm going to draw another right angle triangle over here. Sorry, I'll draw a better one than that. So we've got a right angle triangle here. And this time around, we don't know how long each of the sides are. So what I'm going to do is when we don't know that in algebra, we give them letters. So I'm going to call this A and B, and I'm going to call this diagonal one C. So based on that diagram, we know a bit about Pythagoras' theory. So we know it applies to right angle triangles only. So if you don't have a right angle triangle, Pythagoras' theory will not work for this. There are other rules that will work for non-right angle triangles. The other thing we need to know is if you think of the triangle, those A and B, they join to make that right angle there. So you can see A goes down here, B goes down here, and they form their right angle. So I'm going to write A and B form the right angle. And the final thing, the diagonal, or the one opposite the right angle, that there is C. So C is opposite to the right angle. So now that we know all that, we can write an equation. So we know if we added a square on the A side, so that there is going to be A squared, and we put a square on the B side down here. So let's say we go plus B squared. That should equal to the big square that comes along C side. So A squared plus B squared is equal to C squared. And A and B, the only other thing we need to know, A and B is sometimes called the short sides. And that's because A and B will always be shorter than the diagonal. C is always going to be the longer side of the triangle. And that there means that C squared, that's going to be the long side of our triangle. So guys, for this video, we went through Pythagoras' theory about how it's all about putting squares on the sides of shapes. And we've learnt about the key formula that we're going to be applying for the next week or so about Pythagoras' theory. So thank you so much for watching, guys. Hopefully you get really, really good notes down from this. And then tomorrow we're going to get into heaps of practice.